Hi, everyone, and welcome to Building Custom Design Systems with Jetpack Compose's new Styles API. My name is Rebecca, and with me today on stage we have
Meghan.
And Chuck.
We've seen how Android is evolving to support different device form factors, and how apps are increasingly wanting to stand out from the crowd with their own custom design system definitions. We understand that every app is unique. Many apps use material from a full material-based design system to a full custom design system. And if you fall somewhere in between this spectrum, we are building a framework that works across this. Jetsnack, one of our very first examples we released in Compose, has always been a great showcase of building something custom in Compose that leverages material components under the hood. But its design system has always had its own unique definition, in that it has used a very broad usage of gradients throughout it. The component designs have typically been slightly different from the components that material design offers out of the box. It's used gradients in various different ways, such as this filter chip that has a gradient border for the normal state, and the press state is a solid gradient. Separately, when looking at material components, they come built in with really great defaults. And this is why we love using material. It handles all of these complexities for you, such as accessibility standards, right-to-left positioning, various different interaction states, and components generally look great out of the box. But as we've seen, our designer has given us something that's a little bit more custom. So how would you typically go about this? For this filter chip example, you've likely tried importing the material filter chip, and then immediately tried to set a background color that's a gradient when it's selected. And at this point, you probably see that the API was only designed with a single color in mind, and it doesn't support the brush type. You may, at this point, probably do one of a few things. In this case, I set the colors to transparent, and then surround the chip in a box, and use modifier.background on the box to try and actually set the gradients instead. Then moving the filter chip to be within this box. Things are looking OK with this until we actually try and run them. We can see that we also need to apply the shape to the container too. Not only that, but we also need to build in our own logic to handle pressed and selected states now. So at this point, you might have also decided it was time to fork the material source or create your own version of these components. In Jetsnack, we've created our own components. However, this means that our app is losing all of these benefits of material. So we've been working on something new that we want to preview with you today, called Styles. Styles are a new mechanism in Jetpack Compose for customizing elements. They're designed to separate form from function and unlock easy state-based styling, along with some added performance benefits. The Styles API has been released in version 1.12 of Compose Foundation as experimental, with materials adoption in the APIs coming soon. You'll see this is a big shift in how you interact with components today. We will show you how Styles helps customize your components in an easy-to-use way through a refreshed version of Jetsnack. Still using gradients, just a tad more subtle. I'll give it over to Meghan to tell you more.
Thank you, Rebecca. So let's hop into it. Like we said, we're giving Jetsnack a makeover using the Style API. But you might all be asking, what's a style? A style is an interface that defines the appearance of a component. A style is a specialized modifier that automatically gives performance and reusability benefits. And I really want to stress that styles are not here to replace modifiers, but instead here to replace parameters that are related to visual properties. Let me show you what I mean. As we've mentioned in this talk, we were going to be working with Jetsnack, which uses a custom implementation of button to achieve the gradient effect. And as you can see, this definition of button has many different styling parameters: disabled state, shape, border, etc. But with styles, we can replace all of those lines with a simple style parameter, which provides a standardized set of properties that can be set on any component. OK, so now you know what a style is. Let's see how you would use a style. There are two use cases for adding styles to your components. One is creating a custom component and making it stylable, and the other is using a composable that has a style parameter. So let's look at how to make a custom component stylable. Under the hood, Jetsnack's button is implemented as a row that is clickable. And in order to make the button stylable, you can add a stylable modifier. And then you would add a style parameter to your method signature so that implementations of the custom button can use the style parameter to customize their implementation of the button. And it's always recommended to provide a style parameter on design system components in the same way that you always supply a modifier. Then you'll pass in style state and the style parameter into the stylable modifier. And we're not going to get into style state right now, but we will get into it later in this talk. And now our custom button is ready to use styles. The other use case that you would use is to style a component that has a style parameter, just like the button we just created. Within Jetsnack, we're going to be using the custom implementation of button. And here's what it looks like with nothing in the style block. And let's add some styling in. So here's a list of all the style properties that are available. And as you can see, it's quite comprehensive. Don't get lost in the weeds. It's all on documentation. And we're going to use the background property to update the background to be light gray. In the style block, we add background and pass in light gray. And it's that easy to modify our component using a style property. Of course, yes, we're barely scratching the surface here, and we're going to be going over how to go from what we see here to this button with a gradient, animations, and state-based styling using the Style API in this talk. But before we can get into all of that fun, we have to get into the fundamentals of style. OK, guys, come on. Yeah, laugh, yeah, that's what I want. OK, fundamental one is that style properties override one another. Second is that style properties are inherited. Third is that styles are reusable. And fourth is styles are mergeable. So we're going to demonstrate all four of these while styling our new Jetsnack button. Going back to our button code, we've already used the background property to change the background color to light gray. And just as easily, we can also set other properties on the button. Syntax-wise, we can just add a new line per property. No commas needed. We'll add width, height, shape, font weight, and text alignment. And then let's also add an external padding of 32 dp. And then if I wanted to modify only the top padding, I would add external padding top with 16 dp. And you may expect this to give you 32 dp plus 16 dp of padding. But instead, you only get 16 dp of padding on top. And this is because style properties override one another when the same property is set twice. The button has 32 dp of padding. But since external padding top is the last defined property for the top padding, it will override the top padding, making it 16 dp. If we did this with modifiers, it would add the two paddings together, giving us a top padding of 48 dp. Now, in Jetsnack, we also have a custom text composable that accepts a style parameter. And with that in mind, you may be asking, why are we setting font weight and text align through the button when we could set it through the text style property? After all, these properties affect the text, not the button. So let's investigate text align. If we remove the text align from button style and instead add it directly on text style, we do get the same intended result. And depending on our use case, we would set text align on the button level because certain text style properties are inheritable. By setting the text align on the button level, the text content inherits the text alignment from the parent composable. It doesn't make so much of a difference when there's only one child composable. But if we instead pass this column of text composables as the button content, they would all inherit center text align. But then, if you added direct text align style parameters on a text composable, that would take precedence over the inherited parent composable. Here, add and cart are overriding the center text align, and to is not, so it's still inheriting the button's text align. The lowest item on the precedence totem pole is the parent-defined styles. And then, if you provide a modifier on your component that sets the style, that will have a higher precedence than the parent-defined style. And then finally, setting a direct style parameter has the most precedence. Again, this is only for certain text style properties which are inheritable. So now what we have is a really nice button style, and we may want to use it on multiple buttons in our app. So we can create a style object called button style, and in that block, we can add the same properties that we added to the button style block. And then we could replace all of the button style property with button style. And then, because styles are reusable, our style can be passed into multiple different buttons and provide styling for them. So now let's add in a new style called gradient style for our more special custom styling like shadows and gradients. In it, we can add a drop shadow and an inner shadow. And then if we replace button style with gradient style in our button style block, we lose everything from button style. We lose the width, the height, the shape, the padding, and the text alignment. But what we actually want here is the combination of both the button style and the gradient style. And to do this, we'll use style merging. In the style parameter, we will pass both button style and gradient style by simply adding another argument to the style constructor. Now we can properly see shadows from the gradient style, which adds so much dimension to the button. And now let's add the background gradient. In our gradient style, we can add a brush using a linear gradient. But wait, if you remember, we do have a background defined in the button style and then again in the gradient style. But the gradient style is the background that we're seeing. This is because gradient style comes after button style when we pass them into the style parameter. Remember when we covered style properties being overwritable, that the last defined style property is the one that wins. Since gradient is passed in second, its background property is defined last, so that's what we see. If we switch the order of gradient style and button style, then the gray background would be what the user sees. We still see shadows because gradient style is still being applied. It's only the background property that's overridden because it's defined twice. Note that because styles are overwritable, the gradient background replaces the gray background instead of having gray underneath. And also, syntax-wise, you can use the infix then operator to combine styles together as well. So in this section, we learned about the style fundamentals of being overwritable, inheritable, reusable, and mergeable, and use those fundamentals to build this beautiful gradient button. Yay! Now, let's talk interaction states and styles. So we do have this beautiful button styled, but we want to add styling based on the different interaction states. The Styles API comes with a couple of states built in by default. Default state, when no interactions are happening, pressed state, hovered state, and focus state. Hovered and focus are triggered on devices that have either a mouse attached, and focus is also triggered on devices like TVs that have D-pad navigation. It's good to define all of these styles. It's good to define all of these states for each interactable element, as your users will be using your app with various different device configurations. So we already have button style and gradient style passed into the style parameter, and we could add our state-based styling through a style object, or we could add an inline style block by adding a block after the parentheses, which we decided to do. And in that block, you can add a press block. In our press block, the syntax is the same as within a style block. In order to define the style when the button is pressed, we will add a background property and set it to light purple. And now you can see that when it's pressed, it turns to light purple. Now let's add hovered and focused. Hovered is a lavender background, right here. And then focused is a light purple border. Wait for it to go. And all of our states, yay! So that's basically all you got to do to have your state-based styling for pressed, hovered, and focused. Back to Rebecca.
Now let's chat briefly about animations and styles, my favorite topic. We were able to add state-based styling, which adds so much to your app, but the transition between the states isn't as smooth or as elegant as we would want it. It simply snaps to the end state without any smooth transition. To ease between these different states, you can surround any style property with an animate lambda, and this will perform an automatic transition between the start and defined state within the lambda block. In this example, we set the inner shadow initially to have a 0 dp offset, and then when it's in the hovered state, we change the dp offset inwards of -6 dp and -2 dp. We also move the drop shadow in the same way, resulting in this delightful shadow movement animation on hover. We can add many different properties to be animated here, though. For example, we can also animate the background color to make the buttons change on hover. The nice part is that this cleans up having to track state changes yourself and creating all of those various animator state variables that you may have previously needed to create. To customize these animations, you can also pass in an animation spec into this animation block. Here we pass in a tween spec with a longer duration, just to see the animation slow down a little bit. But we can supply in any other animation spec that you'd like. Now I'll pass it off to Chuck for the next section.
Now let's talk about custom style states and why you'd want to use them. Let's go back to our button definition where we defined the style state and passed it into the stylable modifier. What is that style state anyway? The style state represents the current state of the UI element, which is used for tracking the interaction state, like pressed, hovered, and focused, and is used for state-based styling to select the different style properties based on that state. It allows linking the interaction source to the style itself. Without linking up the state to the style, the code would still compile, but when you press the button, nothing would happen. This is the definition of the style state. The class definition, you can see that there are some states that are built in. You may have noticed at the very end, there's a get operator. This get operator enables custom states because the style state is a map from the style state key to a value. Let's look at an example of how this might be used. In Jetsnack, we wanted the Add to Cart button to look different when we're loading something or when an error occurs. Here we have an updated design for what the different states should look like. Note the design for loaded isn't changed. That makes sense. It's our default. But the design is different for loading and error. To implement these designs, we need to somehow communicate the loading state to the style so we can change the button's look to match the design. This is what custom states are for. To create a custom state, you first need to create a type for the state. For Jetsnack, we wanted to track the state of loading. So we created an enum class that has 3 values that we're interested in: loading, loaded, and error. Next, we needed to create the corresponding style state key. The key is used by the component to record the current state of the loading state into the style state, and later we'll use that same key to read the style in the state itself. When creating a style state key, you need to provide a default value. This should be the value when the state is not special. In our case, it's when we're already loaded. So we use loading state.loaded as the default. To allow a style to read this custom state, we need to add an extension function to style scope that will only execute its block when the custom style state or the custom state is loading. This, for example, is how the pressed is implemented. It only calls its block when isPressed is true. The style scope is the receiver scope of the style lambda, and it introduces the style properties such as padding, background, and border. By extending it, we allow loading to be used to customize the style based on its loading state. The style scope contains a helper function called state for extension functions like loading to use. It requires a key, a block, and an active expression. The key is the key we just created, which is the loading state key. The block is the block parameter. We just pass it on through to state. The block parameter sets the properties that are unique to the loading state. And finally, we have the active lambda, which returns true when we're in the loading state. In this case, we just compare the current state to loading state.loaded, or loading, and that is, we'll set the properties that are unique to the loading state. We can then add another extension function when we're in the error state, which we're going to call loading error, which follows the same pattern as loading. We now go back to the button and update it to take the loading state and to communicate that back to the style. First, we update the button to take a loading state as a parameter. We make the default loading state.loaded, which matches our style state key. Next, we need to update the style state with the loading state. This is done in the same expression that creates the style state. The remember updated style state takes a trailing lambda, which is called whenever the button is recomposed. We use the loading state key to record the loading state into the style state. Now we can customize the button. Here we have a simplified version of the full button, which covers focused, pressed, and hovered. We can now update this to change the look of the button when we're in the loading states, using the extension functions we just created. This is how the style state lambda allows us to override the values of loading and loading error, just as we do pressed, hovered, and focused. Now remember, these are the designs we wanted to implement. And we implement those designs by changing the color from light to light orange when we're loading, and when we're in the error state, we change it to light red. And there, we have implemented a custom state-based styling. I just like looking at it. Anyway, by extending the style state to add loading, now any component that uses style can also use the loading state. For example, this can be used in the Jetsnack card or the filter chip. Now, this is fine for states that are common across many components, but clutters the scope with a bunch of style state functions that may not apply to a particular component. For example, neither the Jetsnack card or the filter chip update the loading state. The loading and loading error state functions should only be available when the loading state is applicable. Ideally, we would want to make loading a syntax error when it's used in a style of a component that doesn't have a loading state. This is what custom styles allow us to do. A custom style allows a component to restrict the style scope to only the properties that are appropriate for it, and also control which extension functions are available. In our case, we would like to control when loading and loading error are visible. Let's see how that is done. Creating a custom style starts by creating what you want to be visible in the scope. For a button, we just want to control how the style is extended, not restricted in any way. So we make the loading style scope inherit directly from style scope. Next, we create a custom style, loading style, using the scope we just created. We then update the extension functions we wrote to extend this new scope instead of style scope. Now these extension functions will only be usable inside of a loading style and are no longer valid in style. Lastly, we go back to the button and we update it to use the new custom style. As the custom loading style is not actually a style type, you need to convert it to a style before we pass it to the stylable property, so we call toStyle on it. Loading and loading error now can be used to customize a button, but not when customizing a filter chip, which is exactly what we wanted. Now you may ask, what's the cost of all this power? Well, surprisingly, styles are usually cheaper than using the corresponding modifiers. The main reason for this is styles make it much easier to use Compose performance best practices. Let's take a look at the best case example. This code is changing the border color of a box and setting a couple other properties. All the benchmarks we've written are much like this, a component implemented with modifiers and the same component implemented with styles. In this benchmark, styles had approximately 70% fewer allocations and used up to 2.3 times faster to render the next pixel. To see how this is done, let's take a closer look at how styles work. Styles are a modifier that only affects layout and draw. When a layout property such as content padding changes, only layout and draw run. If a draw property such as background changes, only the draw phase runs. For the benchmark above, only the draw phase was running to update the next pixel. The performance benefits for styles really comes from three things. Styles are created in composition, but they're only evaluated after composition. As explained earlier, this shifts the work done by a modifier into a later phase of compose, allowing composition to be skipped when a style changes. Styles also use a single modifier. This reduces the number of allocations needed for the same functionality. And there are no animations created during composition. They're only created when they're needed, which reduces the cost of creating the composable in the first place. The border benchmark is a very targeted benchmark to highlight what styles does best. In a more real-world example, we've already seen improvements. In a prototype of materials button implementation, we switched to a style-based version, and the allocations reduced by approximately 37%. And the button was 1.6 times faster to render the next pixel. Now, back to Rebecca to talk about theming.
Thanks, Chuck. So far, we've learned a great deal about styling in Compose with the new APIs. Let's take a look at how you can integrate this into your themes. As mentioned at the start, we know that there is a spectrum of material adoption that your app can have. And the way in which you adopt styles in your theme may differ depending on your level. So, how can you actually adopt styles? The way styles should be integrated with your app is through your theme, by exposing a style object that wraps your default styles for your component. This is a new layer that sits on top of the current subsystems that your design system may provide. For example, in Jetsnack, we have colors, shapes, and typography defined at a theme level. We now introduce a component default style layer into our theme, which is a group of styles that accesses the subsystems for tokens for colors, shapes, and typography. Then, our button composable would use the default style from the theme over directly accessing the subsystems like it used to before. Now, when the button is rendered, it will resolve the style using the precedence hierarchy that Meghan spoke about earlier, and by taking the incoming style parameter on the button, the theme's button style, and the inherited attributes up the tree to resolve the computed style for that button. So if you're not using material design, you can try out styles in your own design system today. If you are in one of these two camps, you're either not using material at all, or you have a custom theme that wraps material components. Our recommendation is to use styles within your own theme components. And when material components expose a style parameter, you can use that in your wrapped component definitions. Let's take a look at the Jetsnack example. This app has its own custom theme, and it uses some of the material components. So we already had our own custom theme set up, with the subsystems like colors, typography, and shapes all being different from material. So to adopt styles, we add our new Jetsnack styles object, exposed as a property on the theme that exposes the static object. We also add style scope extension functions to be able to easily access the subsystem tokens in the style themselves. Styles can access composition locals. Then, in our Jetsnack styles object, we create the default for a component. For example, we remove the button style that we defined earlier into this class. And we switch the hard-coded colors to use theme-level tokens from each subsystem. For example, the background here is set to a linear gradient brush, using the list of colors defined in our custom design system set of colors. This means that the style will automatically change when the subsystems are switched out. In this case, we're switching from dark to light mode, the colors would automatically adapt. Within our design system component definition, we now access the theme-level styles and resolve the effective style by combining the incoming style parameter with the themed style, making our button themable. Now we are able to easily use this button and customize it by passing in an additional style to override particular parameters. In this example, we are passing in different shapes. This, combined with this default style, set at the theme level. You can see that there is also correct light and dark mode theming and of the buttons, since it's using the underlying composition locals. So what about the case when you are using material components? Material is adopting styles within their UI components, which will be available in future releases, starting with Material 3. If you're still using Material 2 components, we encourage you to migrate to Material 3 in the meantime. When using Material, you might be using the whole Material design system, and in that case, you just use the style parameter when it's offered on a component. If your design system is Material 3 based, but you have one or two global differences, you'd then be able to override them at the theme level. With material components that expose a style parameter, you'll be able to customize these components to your heart's content. For example, this Material 3 button will provide a style parameter on it, so you'll be able to use material components without the need of forking the implementation, and instead customize it to your requirements, with a custom background, shape, padding, etc. This allows you to change other properties on a material component that you previously may not have been able to change before. You can learn more about how material is evolving to ensure you benefit from material whilst bringing your own customizations. Check out this talk. Back to Meghan.
So we've talked at length about the Styles API, how you can get set up and integrate into your themes, but there's also a way to make your themes adapt to different device characteristics. We've introduced another experimental API called Media Query. What this API provides is a simple way to access window characteristics, which can unlock building only one theme to use across the device spectrum. The API works hand in hand with the Styles API to provide easy-to-use queries that can change styles based on device properties. Let's look at a quick example. So with Android being able to adapt to more and more devices, you may want to know how you could easily add support for these different adaptations. For example, if you have a mouse attached, your pointer position variable now reports fine pointer position, meaning that you have ability to click on smaller device targets. To change a style property based on a media query, you can use the example as follows. It returns only a single Boolean value, and the style will be invalidated and be re-resolved after composition when the conditional changes. Here, you can see this set of buttons changes padding and size when on a device with the mouse plugged in. The button right at the bottom, let's try it again. The button right at the bottom overall looks smaller, even though we are using the exact same composable. The style will now automatically adjust based on device properties. And you can learn more about the newest Media Query APIs at the link right here. And be sure to check out Make Your UI Adaptive with Android Studio's AI agent, or ask Don and Jose right here. Back to Chuck. Can you stand behind the podium?
I'll stand.
At this point, you may be asking yourself, when should you pick a modifier versus a style? As we've seen, there is some overlap between the two different systems. As a reminder, styles are not meant to replace modifiers, but are instead meant to replace the parameters related to visual properties. When comparing the two, modifiers are designed as low-level capabilities and are still the way to work with behaviors, semantics, additive properties, and complex layouts, whereas styles are a high-level modifier designed for visual appearance, individual sizing, and themable properties. Styles are a level above modifiers, and they're built on top of modifiers. Looking at the logic, modifiers are additive, where styles are override. For theming, with modifiers, it can be quite challenging, as they were not designed to be elevated to the theme level, whereas styles, using them in a theme is by design. Looking at performance between the two, this is nuanced, of course, but styles by design skip composition, whereas modifiers often require all three phases. And with regard to animations, modifiers need separate animation primitives, whereas styles have animations built in. So when you should choose a style or a modifier, well, choose a style when you want to override the defaults for an existing component, perform high-performance interactive state animations, or to define theme-wide sets of properties for a component. And choose modifiers for behaviors like clickable or other gestures to define unique one-off layouts, or if you need to have additive properties on your composable. Now back to Rebecca to wrap us up.
And with that, we'd like to encourage you to try out styles in Compose, and let us know if you have any feedback on the APIs. As a reminder, the API is experimental and subject to change as we receive feedback from you. We have an extensive set of documentation that are already available at this link. Additionally, if you'd like to try out the new styles skill with your own agent that can assist in the migration to use styles with your own custom design system, or just the basic usage in Compose, you can access the skill at the following link, or download the skills using the new Android CLI. Thank you so much for joining us. Check out the resources linked, and let us know what you think of the Styles API.